All right, let's do this. You ready? Okay.
Born ready.
Welcome to Syzygy, episode 23, Exoplanets. Thank you very much. Still people coming into the O2 Arena here for Syzygy Live. My name is Chris Stewart. I am one of two hosts of this podcast. It's a very special edition of the Syzygy podcast. We are live here at YorNight, the YorNight Festival. How's it going, everyone? Everyone's here for an evening of research. It's going to be awesome. Listen, we're going to be doing a very special thing tonight because this is live. We do have an audience, as you can hear, and we're going to be talking about exoplanets. And to help me out with that, my co-podcaster in crime, Dr. Emily Brunson.
Hello, hello.
I should make it clear, you don't have to applaud only when I tell you to. You can spontaneously applaud as well. That's
But every time you mention my name, that's a good time.
Yeah. Now, as I
like
mentioned,
that.
please do come in. That's totally fine. As I mentioned earlier, before we started recording the show, podcasting is an audio medium, right? And so people listening at home can't see that we have actually decorated the room in the most extraordinary style. Emily, I don't know how you managed to do this Milky Way across the ceiling. What did you make that out of?
Stars.
Just unbelievable. And I mean, a lot of the audience have actually turned up in special dress as well. You know, this gentleman in the front row looking like the Horsehead Nebula. It's quite like a staggering homemade costume. The entire back row has done themselves up. I don't know how you've done it, like the Andromeda Galaxy. It's quite extraordinary. So give yourselves a hand for helping us out with the visuals there. Well done. Absolutely amazing. And I think actually what we should probably do to kick this thing off, we should probably actually do a selfie, shouldn't we?
Oh,
Can we do a selfie?
Yeah.
You guys stay where you are. We'll move. That's fine. Okay, ready? Yeah, everyone cheer. All right. Let's get this underway. Now, those of you, of the 28 million people who listen to the podcast, those of you who have listened for a while will know that we have talked on a couple of occasions about exoplanets. Now, if you don't
Slightly fond of them.
Yeah, we are. And we'll get onto that in just a second as to exactly why we're fond of them. But if you don't know what an exoplanet is, right, you know what a planet is. I hope you know. I hope everyone in the room, hands up if you know what a planet is. Good, fantastic, well done. An exoplanet is a planet which is around a different star, right? So we go around the Earth and Mars and Jupiter and all of the other planets in our solar system. We go around our sun. That's a star. There are other stars. This may be news to you, I don't know. But there are other stars, and it turns out that most of them have planets around them, which is amazing. And only something that we really learned not that long ago. Emily, how long have we known about exoplanets?
Well, only about 20 years or so. We
Right.
kind of thought that probably, I mean, if we've got planets, it kind of makes sense that all the other 300 billion stars in our galaxy should also have exoplanets.
Yeah.
But we hadn't found them, and we need to go out there and find them. And who was the best at finding exoplanets?
Anyone? It's got to be Kepler, right?
Kepler.
Yeah. Kepler. Yes, the wonderful exoplanet spotting spacecraft Kepler. Tell us a little bit about Kepler.
So Kepler was mission active in its main part of its exoplanet hunting life from about 2009 to 2013. It had a slight kind of hiccup. It kind of had a sore leg equivalent, which means it couldn't point very well in space. So after that, from 2013 to a few months ago, it was in a special mission called K2, also hunting for exoplanets.
Isn't that great? There's a little take home there for everyone. When something breaks, don't throw it out. Just call it a special mission.
Yeah.
That's totally fine. No, the washing machine's fine. It's just on a special mission of not cleaning stuff.
Yeah. But of course, a couple of weeks ago, Kepler was finally pronounced utterly dead.
Yeah, it ran out of fuel. Didn't it? Which is, there's not a lot you can do. No. You know, when it's run out of fuel, special mission has come to an end. Very sad.
So this is NASA's tribute to Kepler. It is, of course, a kind of an artistic impression of all the wonderful worlds that Kepler has found. And I do have some fabulous statistics for you here. You know I love numbers.
Go on then.
You know I love
Everyone loves a good stat.
All right. So as of today, Kepler has found 2,682 confirmed exoplanets and 2,899 candidates that we're still chasing up to see if they're real.
So, like, we're pushing up towards 6,000, 5,500, 6,000? Wow.
Which is something like 70% of every exoplanets that we know exist.
All down to Kepler.
All to Kepler.
So can we just have just a moment's silence for
Silence?
Kepler?
Kepler deserves an applause.
That's true, actually.
Well done.
There's the other fact that silence really doesn't work on a podcast, does
Yeah.
it? I mean, it does, but people then switch off and go on something else. So, Kepler, we're going to miss it. The good
Yeah.
thing is, Kepler's got a buddy.
Kepler's got a new telescope to pass on the proverbial planet hunting torch to, and that is a wonderful space telescope that launched in April of this year called TESS.
Yeah. Anyone who's listened to the podcast before know that we're TESS fans
Big
here
TESS
at
fans.
Syzygy. In fact, so much so that we actually have a paper model that, can I just point out, can you see the glittery stuff around?
Yeah, the glitter's all me.
Right? That's optional. That's all Emily, right? Emily took this and went, I think it needs more glitter, frankly. So TESS, the Transiting Exoplanet Survey satellite, has taken over, picked up the baton where Kepler left it.
Yeah, and of course NASA had to do a wonderful animation to show us
Yeah.
that it's not just sad that Kepler's finished now, but actually it's really wonderful that we have TESS. And isn't that just the cutest thing ever? Trust NASA to make you fall in love with a piece of space junk, right?
Although actually, factually, what should have happened there is that Kepler, while it was running off, having waved, it should have just gone and fallen over, because that's what actually happened to it, poor thing. So we now have Tess up there scanning the skies for exoplanets, and we thought that for tonight's show, we would delve deep into Emily's knowledge, because let's be absolutely clear, Emily is the astronomer here. I'm just a lapsed physicist. I used to be a physicist, and I'm not even that anymore. So I just turn up each week for these recordings and go, really? Wow. And Emily is the one who actually has the knowledge. And so we've delved into Emily's knowledge about exoplanets, and I asked her, Emily, give us your top three exoplanets of all time. And so, Emily, take us through it. Where are we going to start?
Yeah, well, first of all, I had to choose 3 Kepler planets, right?
Only fair.
Yeah, it's fair to celebrate Kepler's life.
To be reasonable, you do have 2,600 of them to choose from. So,
Yeah, it took me a while.
yeah, been a long day.
Yeah. So, but I did choose 3, and they've got really lovely names. So, number
Hit us.
1,
Yep.
Kepler 78b.
Well done, 78b. Always a classic.
Number 2, Kepler 186f.
Oh, that is a favourite.
Yeah. And number 3, Kepler 64b.
Yeah, I didn't think you were going to choose 64b.
Oh, no, I had to. I had to, really.
Okay, so are we starting in that order?
Yeah, let's
All
go.
right, hit us with it then.
Okay, so exoplanet names are not beautiful, as we've kind of just established. The numbers come from the numbering system of the Kepler. They come from when the planet is confirmed as a new planet. And the letters are actually quite interesting as well. So the letters are lowercase letters, and the B means that it's a planet. It's a lowercase b. So Kepler 78 is actually a star. Kepler 78b is the little planet that's going around it.
And the second planet?
No,
No, that would be obvious.
that would be obvious. No, we don't have A's for planets.
What?
We just couldn't be bothered.
Because astronomy starts with B.
Yeah.
All right, carry on.
So Kepler 78b is the first planet and only planet actually that we've found around Kepler 78.
All right.
So the reason why this is one of my top favorite planets is because a year is only 8.5 hours long.
Get out of town. 8.5 hours for a year. That's not a day, that's a year.
That's a year.
So just remembering, for those of us who might not remember, a year is an entire trip around its star in 8.5 hours.
Yep, so the Earth takes 365.25 days to go around our star. Only 8.5 hours, this
That's
little guy.
nuts. That's going really fast.
It's whipping around.
Yeah.
Yeah. Now, I took the liberty of calculating how old I would be.
How old you would be.
Well,
That's brave.
how old we would be if we were 30.
Yeah, okay.
Shall we
Because,
say?
I mean, I'm quite close to that.
Yeah. We're being
Yeah.
generous here, right?
Yeah.
So a 30-year-old person on Earth would be 30,939 years old on Kepler 78b.
Do you know, I don't feel so bad about being my actual age now.
No.
That's all right.
Can always be worse.
Astronomy, putting things in perspective for hundreds of years. I like it. It's good.
Now, at the time that Kepler 78b was discovered, it was actually very, very exciting. And it was back in November 2013. It was one of the very first Earth-like planets that we'd actually been able to find. Previously, we'd been able to find these really big, hot Jupiter-sized planets that were really, really close to their star. And that's cool, but we're not going to go live there.
No. I mean, really, when it comes down to it, if you were to prod an astronomer very hard with a pointed stick, you would get them to admit that all of this is really just about finding places that we could eventually go and visit. It's not about the research. It's not about trying to push forwards the barriers of knowledge or the frontiers of knowledge. It's about trying to find cool places we could one day send a spaceship to and land on.
Earth 2.0.
Yeah,
that's the
exactly.
holy grail, right?
Exactly.
Of exoplanet science. Yeah, totally. So
this is one of those, right?
yeah, sort of. I mean,
Right.
it was the closest we had at the time. So it's about 1.8 times more bigger than us in both sort of mass and
So
radius.
call it twice as big as the Earth.
Yeah,
Yep.
pretty much. So that, compared to the other planets that we'd found up until that time, that was pretty good going, right? Just a slight problem with it.
One small issue, which is?
Well, the reason why it's going around so fast is because it's going around very, very close to its host star.
Right, because of course the Earth takes a year, 365 and a quarter days, to go around our sun. But the closer in you get, Venus and Mercury, they're going around much faster. How long is Mercury's?
88 days.
88 days, right? Not hours, days. And that's Mercury, and it's a burnt ball of rock. So this thing is going around in 8.5 hours. That's very close. Very close
very
to
close.
its star. So maybe not.
Fortunately, the temperature on this planet is going to be somewhere between 2,000 and 3,000 degrees.
Right. So not so much.
Yeah. Now, I have to stress that any of the pictures you're going to see in this podcast today, if they're not of the Earth, they're not real.
Yeah.
Right?
Yeah, that's not a photograph. That's an artist, right?
Yeah.
Yeah.
So, okay, so this is a little bit bigger than the Earth. That's pretty cool. Now we're going around a star, but really, really, really close.
Hang on, is that to scale?
Yeah.
Really?
Yeah.
Wow. Okay. Now put yourself on that planet and imagine, like, you know how big the sun is in the sky. You hold your thumb up. It's roughly that big. Don't look at the sun. That's a really bad thing to do. But that's roughly how big it is in the sky. Now put yourself on this. How big is that star in the sky of that planet? Holy cow.
It's big.
That's nuts.
It's really big. Yeah, so 2,000 to 3,000 degrees means that you are lava. Your planet is lava.
Yeah.
Which means if you're going to play the lava game,
Yeah.
that's a really difficult.
I hadn't really thought about that. Yeah. Okay. So not so much. Yeah. We're not going to be landing on that one anytime soon.
No, but it is still a very cool planet, and we still have to answer the question. For example, why is it even there?
Yeah. Okay. Why is it even there?
No, we haven't answered.
Oh,
that
I
question
see.
yet.
Right. I thought you meant in this podcast. You're talking generally.
Yeah.
We haven't collectively
Planetary
answered that
science has
question.
not told us why this planet is there yet.
That's nuts.
It
It
probably
should
shouldn't
have
be.
burnt to a cinder and just drifted away a long time ago.
Yeah, it shouldn't really have formed that close, and it shouldn't really have migrated that close. So
Cool.
It's
Cool.
a very mysterious planet.
Okay. Well, that's exoplanet number 1 in our list of 3.
Okay, so number 2 is Kepler 186f. 186f is very, very famous as the red planet. Now, again, I stress that any pictures that we're going to show you that are not the Earth are not photographs, but actually artist impressions based on almost zero information.
Yes, right. Right. There's no science behind that at all. I mean, the Earth bit, we know what that one looks like. That's pretty good. The other one, what is it? It's based on the fact that the planet's in roughly the right position away from the star, and it might be roughly this size, and
We
so
basically
could
just
be
made it up,
possibly.
Chris.
Yeah, we made it up. Okay, right.
Anyway, but there was a little bit that was very exciting about this one. So what is very cool is this is one of the very first planets that we found, which is in what we call a habitable zone. So, yeah, okay, so our previous planet was lava, not so cool. In fact, quite literally not very cool. So this is in a habitable zone. Habitable zones are when you have liquid water is able to exist. So your temperature is going to be somewhere between 0 degrees and 100 degrees.
Somewhere between stupidly cold and stupidly hot.
That's a very, very small range in
It is.
astronomy, right?
Yeah. when you can go to minus 270 something or as high as thousands, then that's quite a small range.
Yeah.
Yeah.
So this is one of the very first planets that was kind of the similar size to Earth that was in one of these habitable zones. And so therefore we just took that idea and ran with it and therefore said, well, it's got oceans, it's got continents, it's got clouds.
Sure it does. Guaranteed.
Maybe.
Guaranteed. And wombats and...
No, drop bears.
Drop-
Don't forget the drop bears.
Leave that for another. It's a whole other podcast.
So you'll notice that this one is an F, which is also quite exciting. Because what does an F tell you about the planet?
B, C, D, E, F. It's the fifth.
It's the fifth planet.
It's the fifth.
Yes.
And do they do these in order outwards from the star, or just in
They
order of
try
discovery?
to, yeah,
Right.
yeah. You have to kind of sometimes do some jiggery pokery, but yeah, you do get there in the eventually. So this is the fifth planet out from the host star. So now we've got a mini system, which is kind of looking a little bit like our own
A bit
solar
like
system.
ours, because we've got 8, yes, count them, 8 planets in our solar system. And that's 5, at least that we know of.
Except all of these 5 are basically within the orbit of Mercury
Wow.
in our own
So
solar
not
system.
even within the orbit of Earth, because it's quite a long way from Earth to the Sun. You could fit a few planets in there. We've got another 2. But this is Mercury to the star, distance of Mercury to the star, and there's 5.
5.
Wow. That's
Yeah.
crowded.
Packing a punch.
Crowded.
But now that makes you saying, well, if we go to Mercury, it's insanely hot.
Yeah.
So how can this planet be so close to its star and be habitable?
Yeah, Emily, I was just thinking that. How does that work?
Well, I'm not making it up. It turns out that the star is not as hot as our sun.
Oh, well, that would work too.
Yeah, it's a really, really cool star. In fact, it's so cool, we call it a red dwarf.
Ah, okay. So it's a cooler star, which means you can be closer to it and not get as stupidly hot and burn to a crisp. In fact, you can have 5 planets quite close to it. But that's still going to be enough for us to go and land on it and have Earth 2.0. So that's good.
Yeah, yeah. Now let's do a thought experiment. And this is why this planet is one of my favorites. Because here on Earth, we have lots of grass, lots of plants, lots of trees, all of the stuff that seems to grow that's not an animal is kind of similar in that it's all green.
Yep.
Now, let's think about what our sun is like. Our sun puts out colours across the entire spectrum.
Yeah,
right?
the old Roy G. Biv.
Yep. The whole
And then
rainbow and then
beyond
everything
that
else as well.
Yeah.
Yeah. But where the sun puts out most of its energy is in the colour green.
Coincidence?
Well, maybe not. Now, you'd think then that plants are therefore green so that they can absorb all this wonderful energy that's coming from the sun. And
Sounds
that would
good.
make sense.
Yep.
Turns out that they're green because they're reflecting that back at you. They're
No, that's
actively
true, isn't it? Because,
rejecting all the green light from the sun.
Yeah, of course. You see something as green because it's bouncing that green light off and sending it back to your eye or sending it up to your eye. And so it's not absorbing it to use for energy. So that's wrong.
So,
And so
I don't
biology's
know,
all wrong.
I'm not very good at biology, but that makes it sound like to me that plants are very stupid.
Email Emily. It's not me.
No, but why? Why would you just give up on your biggest source of energy from the sun? I don't
Now,
know.
are you asking this as a hypothetical question or do you have an answer
Well,
for this?
no, it's true.
Please
that
have an
the
answer for this,
biologists
because
know-
otherwise we're going to get a lot of hate mail from biologists.
Biologists don't really know either. Is the
Okay,
short answer.
cool,
Okay,
right.
we know parts of the puzzle. We know that chlorophyll is the thing that's the chemical that makes plants green, and then that's what they use for photosynthesis, etc., etc., etc. Why that particular chemical and its relationship to the energy output of the sun? I think there's still quite a big question mark.
Okay,
there.
cool. But in this case, right, we've got a yellow sun and we've got green stuff here on Earth. So here we've got a red dwarf. So
Red
dot, dot, dot.
plants.
Red plants could be.
What do you reckon?
Sounds
Red
good.
jungles.
Yeah.
Red grass. Red cows. No, we don't have green
We don't
cows.
have green cows, Emily. That doesn't work.
You can tell I'm not a biologist now, can't you?
They're the cows that don't move around much. They just grow moss. Sloth cows, basically. Yeah.
Red sloth cows.
Yeah. So potentially this planet is going to have red vegetation on it, and it's going to have
It's
different
worth
coloured sun
thinking
in the
about what
sky.
happens when you change the properties of the star that you're going
Yeah.
around as to what happens on that planet itself.
Could have a completely different coloured sky as well, depending on what's in the atmosphere.
Definitely, very
That's
different.
cool.
No, that we definitely know. Sunsets on this planet are going to look really, really
Yeah.
cool. I mean, stuff going to the Caribbean, right?
Yeah.
Let's just go to Kepler 186f.
That's right, and it'll be like that all the time.
Yeah, every sunset.
So red sky and red ground, and it's just very red.
Very, very red.
I like it. So that's number 2.
That's number 2.
What's number 3?
Number 3, we've got also the very sexily named Kepler 64b.
Always a favourite.
Yep. Now, actually, this has another name, this planet. It's called PH1,
Why?
because it also stands for Planet Hunters 1.
Okay.
This was the first exoplanet ever discovered by amateur astronomers and as a part of a group called planethunters.org.
But they don't have one of these. Like,
Well-
this isn't a sort of group of people who just got together and went, I know, we'll do our own satellite and then we'll go and find planets. It doesn't work that way.
Not quite, but it's actually using Kepler data. But it turns out that citizen scientists can make real discoveries too.
Cool.
So these were people who were looking at data from Kepler, and they were able to find a system that has, get this, not one, not two. Okay, you see where I'm going now.
I see where you're going with this. Yeah.
Not three, 4 stars in this system.
What, hang on, what? Stars?
4 stars.
So hang on, this planet is going around not one star, but 4 stars.
Well, it's even more complicated than that.
How does that even work? That's nuts.
It is really nuts. Okay, so stars often come in pairs, right? We call them binaries.
Yeah.
In fact, we think more than half of all the stars in our own galaxy were born in some kind of pairing. And those 2 stars are just merrily going around each other, right? And then you've got a planet, which is going around the pair. And then out off to the side, you've got another pair of stars, which are then going around the planet, which is going around the pair of stars.
That's doing my head in. That's nuts.
Yeah,
that
and
can't
I'm
work.
going to take someone out with my arms and work.
Yes, I mean, you run out of arms to show
Yeah,
it for
definitely.
a start. But that can't be stable, really?
Oh, it's
4 stars
it's real,
and a
yeah.
planet
4
in a-
stars and 1 planet.
So what's that going to look like?
This is one of the most amazing things. This is really challenging how we think about what might a sunset look like on one of these planets? What might day and night be? Every day wouldn't be the same length. It depends on how many suns you have in the sky that particular day. Oh, look, it's Wednesday. We've got 4 suns today.
The astrologers would go nuts with that. That'd be great.
Yeah, I mean, you could predict anything.
Yeah, as opposed to other astrology, which
Yeah.
is very factually based. But anyway,
Yeah, so
Moving
4
on.
stars. And so the chances of having all 4 stars below the horizon is actually fairly small, right? In fact, at any one time, you're likely to have at least 1. So when are you going to get to sleep?
yeah, not very often.
No.
Not very often. That looks like that scene out of Star Wars, doesn't it? And,
Yeah.
with Luke looking moodily over the horizon, being all teenager and broody.
Yeah, but you heard it here on Syzygy. We've got better planets than Tatooine.
Yeah, too right, too right. Wow, that's pretty cool. Any other really good facts about that particular planet?
Well, I'm afraid to tell you that if you do want to go visit this particular system,
Which we do, obviously.
OVS, it's going to take you, if you could travel the very, very, very fastest speed that there is. You could travel at the speed of light.
Yep.
Like, we can't. Nothing can that has mass. But
If you could, let's
you could.
hypothetically here. Yep.
5,000 years to get there.
You're really crushing my dreams
I
here,
mean,
Emily.
I was
You're just-
hoping to hang out
come
just till Halley's
on.
Comet comes around again, not another 5,000 years.
That's just okay. Right. So we're just going to have to rely on Tess to be getting our information for us and finding out somewhere a little bit closer to home.
Yeah, and the good news is that Tess has now found 1 new exoplanet.
Yay! Because it only started up a couple of months ago.
Yeah, actually, we haven't got the first science data
Yeah,
yet. We're
but it's already
expecting
found
that.
one.
It's already found one in the commissioning, which means basically we turned it on and saw if it works. Then we turned it off and saw if that bit worked. Then we turned it on again to see if it still worked.
I'll turn it on, turn it off, turn it on
Yeah,
again.
it still works, which
Excellent.
is the good news.
And it's found one.
And yeah, and just in even that process, we've managed to find a new exoplanet.
Brilliant.
And the wonderful thing about TESS is that you may have heard in the news very, very recently this week that we found a new exoplanet around Barnard's star.
Which is, correct me if I'm wrong, the closest star to us other than the sun. Next one, it's the next one out, isn't it?
After the Proxima
Oh,
Alpha
right,
Centauri
yes, yeah.
system. Yeah, so it's like the second furthest
It's
away.
really close.
Yeah, really, really close.
Yeah.
And this is exactly the kind of system that TESS is going to be able to find for us because it's looking at super bright stars that are super close. And we're going to be able to, for the first time, follow up on those observations and do things like, can we see if there's an atmosphere on this exoplanet?
So we wouldn't have to make stuff up. You know,
We don't have to make
it
up all these-
probably looks like
these
Earth,
lovely
and we
artist
could actually
impressions.
have a look and see what we could see.
Yeah, exactly.
That'd be cool.
So basically, I think we talked about lots of really exciting and new exoplanets. There's almost every possibility out there in our galaxy. We've got 300 billion stars just in our galaxy, which pretty much all of them seem to have an exoplanet on average. Some of them have more. Some of them have up to 7 or even 8 exoplanets that we've already managed to find. And over the next year, this is going to be a huge revolution in finding those exoplanets that are really close to us, and we're going to know more about them than we ever have before. So what really I think I'm going to wrap up with and sort of finish on is, this is a new age, and I am so excited about young people who are growing up at this time, because when I was growing up, exoplanets were kind of, maybe they're a thing, maybe they're real.
They're probably out there.
But every one of my textbooks has been completely rewritten. And now children growing up today, you guys, you young people, they're just part of everyday life. And I'm so excited about that. And I really, really hope that you guys are going to be interested and engaged with all the new and exciting discoveries and start to use your imaginations like we have in thinking about what these worlds are actually going to be like.
Astronomy in the coming years is going to be awesome. Utterly, utterly awesome.
It's looking up, Chris.
It is. It is indeed. Right. I think it's time for some questions. We've got about 10 minutes for some questions, and I can see one person just put their hand up and then got it taken back down again, interestingly. So we'll see whether or not we come back to that one. I've got a roving microphone, so if you could just put your hand up if you have a question, I'll come and find you and pass you the microphone, and you can ask it, and we'll take it from there. So who's our first question asker? Shall I come over here? We got a question over here? Have you got a question?
Why do planets orbit the sun?
Why do planets orbit the sun?
That's a
Over to you, Emily.
fantastic question. So we have this wonderful force, which is called gravity, right? Do you know what gravity does to you on Earth? What does it do? Keeps you on the ground. Can you give me an example? Have you got something you can lift up? What have you got in front of you? Yep, lift it up, lift it up. Very nice. Now drop it down. Yeah, go gravity.
That was a demonstration of gravity. Well done.
Yeah, fantastic. So gravity is exactly the same thing that causes us to go around the sun, except instead of falling towards the sun, we basically fall in a circle that goes around and 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 around, and you get the point.
Yeah, we do.
Yeah.
So you're basically, we on the Earth, we're always falling towards the sun, just not getting any closer. It's a bit weird that way.
We keep falling and missing.
Yeah.
Which
Anyone
is a good thing.
ever read Douglas Adams? That's how you fly. You throw yourself at the ground and miss. Well, we're kind of doing that. We're always falling. Another question. Gentleman here.
Are you familiar with Carl Sagan's equation when he came up with, I think, 10 planets that could support people like us?
I'm not familiar with the specifics of that one, but do you want to elaborate?
So just with all the work going on now, do you think that figure's going to go higher than 10?
Oh, I think, so statistically, is it likely that we can find a planet that we could live on? That is probably quite high, I think, the statistics, because we're pretty good at measuring the inputs to that equation. We know how many planets roughly there are in our galaxy, thanks to Kepler. We know roughly how many of them are in this habitable zone where you might get water and therefore life is going to work out okay. So we have good numbers for those, and the numbers are pretty high, which is why we're still trying to find lots that are close to us and do some more searching. If you want to follow that train of thought and think, is there alien life on any of those planets? Now, we don't have good statistics here. This is where it all falls down, right? We don't know how often life
That's an understatement.
forms.
Yeah.
We don't know.
We have an N of 1.
We don't know how often life survives forming. We don't know how often life becomes intelligent. We don't know how often
It's
life
debatable that that's even true here.
becomes communicative, right? So, yeah, that's really hard. We have one sample, and any scientist tonight is going to tell you a sample of one is really rubbish science.
It's a bit hard to extrapolate a line from that. The other thing, of course, is that even if we did find, let's say even around the nearest star to us, hey, perfect, let's go there. It's going to take a really, really, really long time, if ever, for us to get the technology. We're going to Mars first, right? Anyone here want to go and live on Mars? No, put your hands down, because it's going to be really, really bad, right? It's going to be just awful. Anyone who wants to go there, good luck to them, but I'm going to leave them with it. That's where we have to go first, and I don't think that's going to be a fun ride. Okay, I'm going to do this gentleman here, and then I'm going to come back to you, okay?
I was just thinking, when you said about Mars, I don't think I would like to live there if it was the last place on Earth, do you?
Boom, boom. I'm leaving that one in the podcast. That was great. Thank you very much. Okay.
How many dwarf planets are there?
Dwarf planets.
Oh,
Do you mean in our solar system, or do you mean everywhere in the whole universe? Sorry?
Everywhere.
Everywhere.
Count them, Emily. Come on.
Oh, hang on.
What do you do with your time?
Okay, so we officially have 3 in our solar system, right? Pluto is one of them. Sol's Pluto.
Yep.
Now, we have not found any dwarf planets outside of our solar system because they're insanely hard to see, right? They're super tiny and they're really, really far away from their stars.
I mean, Emily said before that the first exoplanets that we discovered, and I'm including myself in that, is that they were really, really big, right? They were Jupiter-sized or super Jupiter-sized. They're these huge things, which makes sense, right? Because if you're going to be looking for something a really long way away, the first ones you're going to see are the really big ones. If you're looking out across the African savannas, you're not going to see the little gopher-y things. You're going to see the elephants, aren't you? So the first exoplanets that we found were huge, and then all the astronomers went, the universe is full of huge planets. And then someone eventually went, no, it's the elephant thing. Oh, right. And then we figured out that there might be some smaller ones. Yeah. Turns out there's even more of those, actually.
But let's do some maths, right?
Okay,
let's say, very quick maths. It's good maths. It's got big numbers in it, my favorite, right? Let's say we've got 3 dwarf planets in our solar system, right?
3's not a really big number, Emily. I'm sorry. You just failed that one.
There are 300 billion stars in our galaxy.
Okay, fair enough.
Let's pretend that 2/3 of those, 200 billion of those stars have planets around them. What's 200 billion times 3?
What's 2 times 3? 2 times 3? 6. So 200 billion times 3 is 600 billion. 600 billion? Is that a good number for you? 600 billion dwarf planets.
No, hang on, Chris. That's just our galaxy.
Oh, that's just our galaxy.
That's just our galaxy.
How many galaxies are there?
About 100 billion.
So multiply that by 100 billion, and you've got a very, 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 very large number. Okay? There you go. Yes, fantastic. Astronomers get very excited by really big numbers, so we had to get there eventually tonight. And then we've probably got time for 1 or 2 more questions. Got a question here? Fantastic.
Why does the sun shine onto the earth?
Why does the sun shine onto the earth? That's a really awesome question.
Now, I'm going to blow your mind here a little bit. The sun shines everywhere at the same time.
True story.
Yeah.
True story. It's not just
So,
us.
you know how we go around the Earth? There's always a day and a night, no matter where we are. If we're in summer, we're on one side of the sun. When we're in winter, we're on the other side of the sun. Okay, the days are kind of shorter and longer, but we still get day and night. You get a day and a night every single day, right? So that means that the sun is shining in all directions all at once, which I think is pretty cool.
Yeah, it is pretty cool.
I like the sun.
Yeah.
Yeah, does a good job.
Where does the sunshine come from?
Oh, now
That's a deeper question, right? Why does the sun shine?
Why does the sun shine?
Yeah.
So it turns out that the sun is a giant atom crushing machine.
Wow.
Much, much better than any atom smashing, atom crushing machines that we have here on Earth, right? Now, the sun has temperatures of millions and millions of degrees, which means it can squeeze things down really, really tightly, pack them together in the center, and that causes them to break apart, or sorry, to fuse together, and then when you get hydrogen fusing into helium, then you get some energy put out as kind of the byproduct.
So basically, the sun takes some of its stuff and squeezes it really hard and turns it into energy, which is light, which shines down on us.
And if you want to know more about that, I know the Sun Dome is out here tonight. So if you go and find the Sun Dome, which is part of the York...
Like a big inflatable dome, isn't it?
It's a big dome. It blows up. It looks like the sun. I mean, not explodes, blows up,
No,
but like
no.
inflatable blows up, yeah.
That would be just wrong. You shouldn't do that.
Go and have a look at that, because that will tell you all about how the sun shines and
really
why
cool.
we want to make the sun shine here on Earth as well.
Okay, got time for one more question. So,
how do you know that things on other planets need water to survive?
That's
how do we know? Well, for starters,
fantastic
I don't. But Emily, how do we know?
That's such a good question, and I love where this question is going, because, okay, so we have one example of how life works, right? We've got it here on Earth. And as far as we can tell, all life on Earth is somehow linked to the fact that water is liquid, whether that's because the plants that we have on Earth use water as part of their growth processes. We've got algae in the oceans, really uninteresting biological muck basically still needs water. So it's not necessarily true that all life in the universe needs water. But we are going for the easy stuff first as astronomers, right? We are going for the stuff that we understand how it works. We know water is useful to life, and we know the impact that life has on our planet. So if we think about if we were to look at Earth and work out if life was living there, we know what signs we're looking for, right? And so we can use that and go and look at other exoplanets and say, do we see the same things that say maybe there's life there? You could make life out of all sorts of weird and wonderful molecules, and that probably does happen somewhere in the universe. But
Again,
give
we've
us a
got
bit
an
of
N
chance.
of one, haven't we? So.
Yeah. Give us a bit of a chance to work out how it works with water first, and then we'll get back to you on the other interesting stuff.
All right, well, that pretty much brings us to the end. Some of you may have noticed that I've just strapped on a guitar because Chris Hadfield. So I thought we'd end with, I've penned a little song called the Exoplanet Song. And when we get to the end of this one, that'll be the end of the podcast. Emily will sign us off, and you guys can just cheer like berserk people, okay? So this is the Exoplanet Song. Sing along if you know the words. Earth is great. It's probably in my top 8 planets that go around the sun. Might even be my number 1, but I'm not sure. I want to be stuck here forevermore. With so many other worlds to find. Some of them would blow your mind. I'm not saying I want to move to Mars. I just want to know what's going on around other stars. I want to live on an exoplanet. Don't you want to live on an exoplanet too? Just me and you. We could have such fun on an exoplanet, jumping up and down in its lower gravity. Just you and me. We could pick a shiny new exoplanet with shimmering rings of ice around it. Moons, so many moons. Moons with their own moons. They're called moons. It's true, we did it in Syzygy episode 19. Go and look it up. Earth has one big, bright, warm and golden sun. It rises every single morning, sets again each evening. That's boring, cause I want 2 or 3 or 4 or even more. Why settle for a single star when a multiple system's better by far? Just like Luke Skywalker on Tatooine. Double sunsets, what I want to see. I want to live on an exoplanet. Don't you want to live on an exoplanet too? Just me and you. We could have such fun on an exoplanet, jumping up and down in its lower gravity. Just you and me. Or pick a planet with a much greater mass and have to drag ourselves around on our asses. We just have to lie on the purple grass beneath the bright green sky. Depends on how we get there, but it might take a while. Give or take, it's roughly 50 billion miles. But when you get the look around, you'll think you're delirious. But I'm not joking, this is serious. Get it? Because that Sirius is the name of a star. Well, if you don't like that one, we can try the rock that's in orbit around Proxima Centauri. Walking on the beach by a glowing sea of lava. Maybe we can meet some of the local exofauna, like fluffy green mice with teeth like piranhas, or giant yellow bats that hang in bunches like bananas, or tinkling clouds of crystal butterflies, or pandas that shoot lasers from their eyes. Yeah, pandas that shoot lasers from their eyes. No? I want to live on an exoplanet. Don't you want to live on an exoplanet too? Exo me, exo you. We could have such fun on an exoplanet, jumping up and down in its lower gravity. Just exo you, exo me.
A big thanks to the University of York and YorNight team for having us along this evening. And thanks to all you guys, our live audience. You can find the Syzygy podcast online at syzygy.fm, that's SYZYGY.fm, on Twitter at SyzygyPod, or just search for us on Facebook. This episode of Syzygy has been produced by my co-host Chris Stewart. I'm Emily Brunston, and we'll catch you next week to explore more of our wonderful universe.
Sing along if you know the words. I want to live on an exoplanet. Don't you want to live on an exoplanet too? Just exo me, exo you. Having exo fun on an exoplanet, jumping up and down in its lower gravity. Just exo you, exo me. I've got my eye on an exoplanet. Let me borrow tests and I'll go and scan it, and you can come there too. The spaceship's leaving at 2:15. But before we do this planet hopping, it's a long way and we're not stopping. So if you want to come too, I really do suggest that you, before we go, I really think that you just should pop into the loo. Thank you very much, ladies and gentlemen. This has been Syzygy Live. Dr. Emily Brunston. I've been Chris Stewart. You've been a fabulous audience. Good night. Yeah, just make yourselves heard, because this is a live show, and if it goes out and it sounds a little bit like just Emily and me talking to an empty room, then that sounds fraudulent, doesn't it? People are going to be listening to that at home and going, you didn't have an audience at all. So I want you guys to make sure that you show that you're here. That doesn't mean heckling. Heckling's not allowed. You're not allowed to from up the back. That's wrong. That's rubbish. The world's flat. If you think the world's flat, we'll talk about that later. Not now. God, what am I doing?
No Pluto either.
And no
Pluto's bad.
Pluto either. We'll talk, if you're here because you've got a bone to pick about Pluto, please save it for after, okay? Not during the show.